You know, when you see a massive cargo ship, a polar icebreaker, or even a luxury superyacht, it's easy to forget what you're really looking at. These aren't just boats. They are some of the most complex moving objects humanity has ever built. They're basically floating cities, mobile factories, just incredible feats of engineering. But every single one of them starts as just an idea.
And that idea becomes a blueprint, a kind of digital dream that is just mind-boggling in its complexity. I mean, look at this. Every single line, every curve, every plate of steel has to be perfectly planned to survive some of the most brutal environments on the planet. It's an absolutely staggering engineering challenge, and it's what keeps global trade and exploration moving.
So, the big question is, how? How does this crazy web of lines and numbers actually become a real physical vessel that can haul thousands of tons across an entire ocean? Who is the master planner behind it all? Well, let's dive in and find out.
All right, so here's the game plan. We're going to break down the role of this master planner. We'll trace the incredible journey from a simple sketch to solid steel. Then we'll peek inside the high-tech digital shipyard where they work. And finally, we'll look at how you could actually become an architect of the seas.
Okay, so that big question, how do these things get built? The answer really starts with one very specific job title. It's a role that's often misunderstood, but it is absolutely central to the whole process: the naval architect.
So what is a naval architect? Put simply, they're the engineer who designs, builds, and maintains pretty much anything that floats. It's this wild role that mashes up mechanical, electrical, software, and safety engineering all into one. They are there from the very first spark of an idea, all the way to the final tests out on the open water.
And this quote from naval architect Nick Tillett really nails it. They have to see the big picture. They're not just designers locked away in an office. They're the central link, the hub that connects what the client wants with what the shipyard can actually build, all while making sure the final ship is safe, efficient, and, yeah, looks good.
Now, a lot of people get them confused with marine engineers. Here's a simple way to think about it. The naval architect is all about the what and the why of the ship, its basic shape, its structure, and how it's going to behave in the water. The marine engineer? They're focused on the how it works. You know, the engines, the power grids, the steering, the HVAC, all the systems that actually bring the architect's design to life.
So how does that design actually take shape? Well, it's not a simple straight line from A to B. It's this really cool iterative process that's known as the design spiral. The idea is that each step influences the next one, and the architects are constantly looping back to tweak and refine their earlier decisions.
It all kicks off in what's called the pre-contract stage, just laying out the basic plan. Then, using a ton of data and, frankly, experience, they create a preliminary hull shape. After that, they get into the really nitty-gritty structural design, the ship's skeleton, basically. And finally, they produce these incredibly detailed construction drawings that tell the shipyards exactly how to build it, down to the last nut and bolt.
And this quote right here from Bart DeHaan just perfectly sums up the insane balancing act they're always performing. It's a constant trade-off. If you use too much steel, sure, it's strong, but the ship is heavy, slow, and inefficient. Use too little, and you've got a weak structure that just isn't safe. It's all about finding that perfect, optimized sweet spot.
So how in the world do they pull off this kind of precision today? Well, they're working in what you could call a digital shipyard, using this incredible suite of specialized software. Let's take a quick run through their modern toolkit.
A lot of the time, it starts with 3D CAD software, something like SolidWorks. This is where they build a complete digital twin of the vessel, modeling every single complex part before a single piece of metal is even cut. Next up, they bring in the heavy hitters, computational fluid dynamics, or CFD tools, like ANSYS Fluent. And this is a total game changer. It lets them simulate exactly how water and air will flow around the hull, so they can optimize the shape for pure efficiency and performance.
Then you've got specialized software like MaxSurf. This is what answers the most critical questions, right? How will the ship actually sit in the water? How much power is it going to need? And, probably most important of all, is it going to be stable and safe no matter what the ocean throws at it? And what's really cool is that it's not all super expensive proprietary software. There are powerful open source tools like OpenFOAM being used all over the industry. It just goes to show you that this kind of cutting-edge design is more accessible than ever.
But listen, behind all of this amazing technology, it's still about the people. It's about the architects themselves. So what's it actually like to do this job day to day?
So what's a typical day?
Well, according to the pros in the field, there's literally no such thing, and that's what makes the job so great. The tasks are always changing, depending on what stage the project is in.
I mean, in a single week, you could be at your computer designing new structures, and the next day you're on site with a hard hat, supervising construction. You might be running incline tests to physically measure a ship's center of gravity, or planning a complex towing operation, or talking directly with a client, giving them technical advice. It's a career that constantly jumps between the digital world and the very real, very physical world of the shipyard.
But maybe the best part, the ultimate reward of the job, is seeing the whole thing through from start to finish. I mean, think about it. There aren't many jobs where you get to be involved from the very first sketch on a piece of paper all the way to standing on the deck of the finished vessel as it sails out for its very first sea trials. That's got to be an incredible feeling.
So if that sounds like a career you can get excited about, what's the actual path to becoming an architect of the seas? And what does the future of this whole profession even look like?
Well, the professionals we heard from pretty much boil it down to 3 key steps. First, you got to study. Get a degree in naval architecture or a related field. Second, get your hands dirty. Go after internships. They say even a job sweeping the floor of a metal workshop teaches you invaluable lessons you'll never learn in a classroom. And third, network. Just talk to people who are already doing the job.
And you'd be getting into a field with a serious future. As project manager Timu Twamisto points out, the marine industry is right at the forefront of massive change and innovation. With huge challenges like decarbonization, the demand for brilliant engineers and designers has never been higher.
Which really leaves us with one final big thought. We are entering an era of absolutely massive change in shipping. We're talking new fuels, smarter systems, even fully autonomous vessels. Now, the fundamental physics aren't going to change, but the tools and the ships themselves, they're going to be radically different. So what kind of incredible vessel will the naval architect of tomorrow get to create?